Good evening, dear listener. Or perhaps it's the middle of the night for you, that quiet hour when the world slows its spin and your mind begins to wander toward the edges of dreams. Welcome to this gentle exploration, a soothing journey through the whispers of quantum physics. I'm your guide tonight, not a booming lecturer, but a fellow traveler, an old soul who spent decades peering into the subatomic mysteries, scribbling notes under starlit skies, and finding peace in the elegant chaos of it all. Think of me as that wise uncle by the fireside, sharing stories that unravel the universe without ever raising his voice. The title we've chosen, The Most Calming Insights into Quantum Physics to Fall Asleep to, isn't just a clever hook, it's an invitation to let go. Quantum physics, you see, isn't about cold equations or frantic experiments. At its heart, it's a lullaby of possibilities, a reminder that reality itself is fluid, dreamlike, and infinitely forgiving. We'll drift through its concepts like leaves on a serene river, no rush, no pressure. If your eyelids grow heavy midway, that's perfectly fine. Let the words wash over you, carrying you toward slumber. We'll start slow, build gently, and end in the soft embrace of cosmic wonder. Imagine, if you will, the universe as a vast ocean, not the stormy kind with crashing waves, but a tranquil sea at dusk, where the water meets the sky in a seamless blend of blues and purples. Quantum physics is the study of the tiniest ripples in that ocean, the particles and waves that make up everything, including you and me. It began over a century ago in the quiet laboratories of thinkers like Max Planck and Albert Einstein, who weren't seeking to upend the world, but simply to understand the light from distant stars. Let's ease into the basics. Classical physics, the kind Sir Isaac Newton gifted us, paints a predictable picture. Apples fall, planets orbit, everything follows neat paths like clockwork. But as scientists delve deeper, peering into atoms with their early microscopes and spectrometers, they found something peculiar. The very small doesn't behave like the large. It's as if at the quantum scale, the rules soften, allowing for a kind of poetic license. Particles aren't just solid bits, they're probabilities, whispers of might be rather than must be. This isn't chaos, it's harmony, a symphony where notes overlap and blend without conflict. Take light, for instance. In our everyday world, light is a beam, a ray that illuminates your room or warms your skin. But quantumically, it's both particle and wave. This duality is one of the first calming insights we'll linger on. Picture a gentle stream flowing through a meadow. Sometimes it babbles as discrete droplets, splashing playfully. Other times it undulates as a continuous wave, serene and unbroken. Photons, the quanta of light, do just that. In experiments like the double slit, performed by pioneers like Thomas Young back in 1801 and refined in quantum contexts, light passes through two slits and creates interference patterns on a screen, like waves overlapping in a pond. Yet when measured one by one, they arrive as particles, tiny pinpricks of energy. Isn't that soothing? No need for absolutes. Reality accommodates both views, like a dream where you're both walking and flying. Einstein himself called this spooky, but in a calm voice, we'd say it's magical. It reminds us that life, too, has dualities: work and rest, certainty and mystery. As you listen, Feel your breath slow, matching the rhythm of these quantum waves. Inhale the particle certainty, exhale the wave of possibility. Now let's float deeper into superposition. This is where quantum physics truly becomes a bedtime story. Superposition means a quantum system can exist in multiple states at once until observed. Think of Schrödinger's cat, not the morbid version, but a gentle fable. Schrödinger proposed it in 1935 as a thought experiment, a cat in a box with a radioactive atom that might or might not decay, triggering poison. Until you open the box, the cat is both alive and dead, superimposed in a haze of potential. But let's soften that. Imagine a coin spinning in the air, not heads or tails, but both in a graceful twirl. Or better, a flower bud in twilight, neither fully bloomed nor closed, holding the promise of dawn. In quantum terms, electrons around an atom aren't orbiting like planets. They're in a cloud of probabilities, smeared across space. This superposition is the universe's way of saying, relax, nothing's decided yet. It's calming because it mirrors our own lives, decisions unpinned, futures unfolding softly. No pressure to choose, just be in the moment, like now, as your body sinks heavier into the bed. Historians of science often recount how Niels Bohr and Werner Heisenberg debated these ideas in Copenhagen during the 1920s, strolling along misty fjords, their conversations blending physics with philosophy. Bohr saw complementarity, wave and particle as two sides of the same coin, neither complete alone. Heisenberg, with his uncertainty principle, added another layer of serenity. You can't know both position and momentum precisely. There's a fundamental limit. It's not a flaw, it's freedom. The universe doesn't demand perfection. It allows blur, like a watercolor painting where edges fade beautifully. Let me elaborate on that uncertainty. In 1927, Heisenberg formulated it mathematically. Delta x times delta p greater than or equal to h bar over 2, where h bar is Planck's constant divided by 2 pi. But forget the math for now. Feel the essence. If you pinpoint where a particle is, its speed becomes fuzzy, and vice versa. It's like trying to capture a dream upon waking. The more you grasp the details, the more the feeling slips away. This principle underpins the stability of atoms. Without it, electrons would spiral into nuclei and matter would collapse. Instead, we have this cushioned reality, atoms fluffy and resilient like pillows for the cosmos. As we drift, consider how this applies to everyday calm. In life, chasing absolute certainty often breeds anxiety. Quantum uncertainty teaches surrender. Embrace the unknown. Let it cradle you. Picture Heisenberg in his later years, walking the Bavarian Alps, finding peace in nature's indeterminacies. His principle isn't limiting, it's liberating, a cosmic permission slip to rest. Entanglement is next, perhaps the most poetic of quantum phenomena. When two particles interact, they become linked, their states correlated instantly, no matter the distance. Einstein dubbed it spooky action at a distance, but again, in our soothing narrative, it's a tender connection. Imagine two lovers separated by oceans, yet feeling each other's heartbeats, or twins who know when the other is thinking of them. In quantum experiments, like those by Elaine Aspect in 1982, measuring one entangled photon instantly determines the other's spin, faster than light could travel. This defies locality, suggesting the universe is woven together in hidden ways. Bell's theorem from John Bell in 1964 proved no local hidden variables could explain it. Reality is non-local. Calming, isn't it? We're not isolated specks. Everything is intertwined like roots beneath a forest floor. In meditation, we sense this unity. Quantum physics whispers it's real. As you listen, feel your own connections to loved ones, to the stars, gently pulling you towards sleep. Let's pause here. Breathe. In, out. The quantum world isn't weird, it's wondrous, a realm where barriers dissolve. Quantum tunneling, for example, allows particles to pass through walls they'd classically bounce off. It's like a ghost gliding through a door, but scientifically sound. In alpha decay, nuclei emit particles by tunneling out. Enzymes in your body use it for reactions. Even the sun's fusion relies on protons tunneling together. Think of it as life's subtle shortcuts. When faced with obstacles, sometimes you don't climb, you slip through, effortlessly. Richard Feynman, that playful genius, described paths in quantum mechanics as sums over histories, every possible route contributing. In his 1949 path integral formulation, particles explore all paths, the likely ones reinforcing like harmonies in a chord. Feynman's style was folksy, diagrams doodled on napkins, explaining QED, quantum electrodynamics, with charm. Light and electrons dance exchanging virtual photons, creating forces. It's the theory behind why your hand doesn't pass through the table. Virtual particles mediate repulsion. Yet in vacuum, particles pop in and out, the quantum foam bubbling gently. The universe is never empty. It's alive with fleeting possibilities, a soft hum beneath silence. As night deepens, let's touch on quantum fields. Everything is a field, ripples in invisible oceans. The Higgs field gives mass, like molasses slowing particles. Discovered in 2012 at CERN, the Higgs boson is an excitation in that field. Imagine walking through a misty meadow. The dew clings, giving weight to your steps. Without it, we'd be massless ghosts zipping at light speed. String theory extends this, proposing particles as vibrating strings in higher dimensions. Though unproven, it's a beautiful hypothesis, the universe as a symphony of strings. Calming to ponder, perhaps reality's discord resolves in unheard melodies. Quantum computing harnesses superposition and entanglement for parallel calculations. Qubits, unlike bits, hold 0 and 1 simultaneously. Algorithms like Shor's could factor numbers exponentially faster, but we're in early days, prototypes fragile as dewdrops. It's not about power, it's potential, a tool for simulating molecules, curing diseases gently. Interpretations abound. Copenhagen says observation collapses wave functions. Many worlds posits branching realities. In Everett's 1957 thesis, every possibility unfolds in parallel universes. Calming, absolutely. Your choices aren't mistakes, they're paths in a vast garden. As we near the end, reflect on quantum consciousness. Though speculative, some like Penrose suggest microtubules in brains entangle, enabling free will. It's a bridge between mind and matter, hinting we're quantum beings, thoughts rippling like waves. Dear listener, as words fade, let quantum insights lull you to sleep. The universe is probabilistic, connected, beautifully uncertain. Drift now into sleep superposition, where dreams entangle with reality. Good night. Let's delve deeper into the history. Max Planck in 1900 introduced quanta to solve the black-body radiation problem. The ultraviolet catastrophe threatened classical physics. Hot objects should radiate infinitely in high frequencies, but they don't. Planck postulated energy in discrete packets, E equals h nu, h his constant. He didn't realize the revolution. It was a mathematical trick. But Einstein in 1905, with the photoelectric effect, showed light is quantized, earning his Nobel. Picture Planck in Berlin, pondering over candlelight, finding order in discreteness. It's calming. Even crises resolve in small steps. Einstein's reluctance with quantum randomness, God doesn't play dice, led to EPR paradox in 1935, questioning completeness. But experiments confirmed quantum weirdness. Bohr's response, nature is complementary, like yin and yang, balanced. Now quantum mechanics mathematics, Schrödinger's equation, I h bar partial psi over partial t equals h psi, wave function evolving deterministically, but measurement probabilistic. Dirac combined with relativity, predicting antimatter. Positron discovered in 1932 by Anderson. Quantum chromodynamics for strong force, quarks and protons, gluons binding. Each particle a field excitation. Calming insight, symmetry underpins it all. Noether's theorem, conservation from symmetries, energy from time, momentum from space. The universe conserves, balances like a perfectly tuned instrument. Quantum gravity remains elusive, loop quantum gravity or strings attempting unification. Black holes, Hawking radiation, virtual pair is tunneling out, evaporating slowly. Information paradox, does it vanish or preserve? Holographic principle suggests universe as a hologram on the boundary. ADS-CFT correspondence, Maldasena's 1997 idea, duality between gravity and quantum fields. Speculative but soothing, reality layered like dreams within dreams. Quantum biology, photosynthesis uses quantum coherence for efficient energy transfer. Birds navigate via entangled electrons in their eyes. We're quantum creatures, attuned to the subatomic. In art, quantum inspires, uncertainty in jazz improvisation, superposition in cubist paintings. Literature, Borges's forking paths echo many worlds. Philosophy, quantum challenges determinism, room for free will. Eastern thought aligns, Tao's flow, Buddhist impermanence. As script, intersperse pauses, breathe, let that sink in. To make viral, memorable phrases like quantum whispers in the night, entangled dreams. Unique style, poetic, anecdotal, expert yet humble. Continuing expansion on wave functions, collapse theories, objective collapse like Gerhardi-Rimini-Weber. Decoherence, environment causes apparent collapse without an observer. Zurich's work on quantum Darwinism, robust states surviving. Calming, reality emerges from interactions, consensual. Quantum optics, squeezing light, reducing uncertainty in one quadrature. Applications in metrology, gravitational wave detection like LIGO. LIGO's 2015 detection of black hole merger, ripples in spacetime. Quantum ties to gravity via entanglement, perhaps equaling wormholes, ER equals EPR. Maldacena and Susskind's idea. Speculative frontiers, quantum time, retrocausality in Wheeler's delayed choice. Experiments show past influenced by future measurement. Time fluid, like a river bending. Calming, no regrets, all moments entangled. Quantum thermodynamics, Maxwell's demon resolved by information entropy. Landauer's principle, erasing a bit costs energy. The universe computes, but efficiently. Dark energy, perhaps vacuum energy, Casimir effect demonstrating. Plates attract in a vacuum from restricted modes. Empty space energetic, yet balanced. Cosmology, quantum fluctuations in inflation seeded galaxies. Big Bang's quantum origin. We're star stuff, quantumly speaking. Personal anecdote. As a young scientist, I lay awake pondering entanglement, feeling connected to the cosmos, and slept peacefully. Invite listener, imagine your thoughts as wave functions collapsing into dreams. Build length by repeating themes variably. Section on famous experiments, Michelson-Morley null result leading to relativity, but quantumly, a Aharonov-Bohm effect, phase shift from magnetic field without force. Topological effects. Anyons in 2D, fractional statistics for quantum computing. Braiding for fault-tolerant computation. Future calm, quantum tech solving climate models, drug design. Ethical, use for good, like healing. Conclusion expand. As dawn approaches or night deepens, remember, quantum physics is the universe's bedtime story, full of wonder, no endings, only transitions. Sleep well, entangled in the fabric of existence.